Hi everybody, in this video we're going to be talking about evaluating functions, but I realize that the notation for functions is a little confusing, so before we evaluate them, let's just go through the notation once more. So what in the world is f of x? So this is pronounced f of x, and basically what it means is the function f is a rule which is going to do something to x. So we are going to be plugging in values for x, and this whole thing will give us an output. So when we are using this notation, f is just the name of the function. That's all. X is the input of the function, and y is the output. And so in all cases, y is the same as f of x. So when we're evaluating functions, what we're really doing is we're plugging in values for x. So this is our goal for this video, is to understand what it means to evaluate a function. And the idea is that we're plugging in inputs and finding the output. Okay, so first we'll do some examples where we evaluate algebraically. So here's our function. It eats x and it spits out 3 minus 2x. So for me to evaluate f of -1, what I need to do is just plug in -1. So I get 3 minus 2 times -1, and that's going to be 3 minus -2, which is the same as 3 plus 2, which is the same as 5. It's as simple as that. So f of 0, I now plug in 0, so 3 minus 2 times 0, and that's the same as 3 minus 0, which is 3. F of 2, same idea, just plug in 2 for x. So 3 minus 4, which is -1. So evaluate algebraically just means to plug in the input into the equation. So here's a slightly more complicated example. We have g of s equals -s squared plus 4s plus 1. So let me slide this up. So to do g of 2, I do the same thing I did above. I just plug in 2. So I get minus 2 squared plus 4 times 2 plus 1. So really the fact that this is s instead of x and the fact that this is g instead of f, it doesn't mean anything. This is just a name for the function, and this is just what we're going to be plugging the inputs into. It's a placeholder. So I could write this exact same function as f of x equals -x squared plus 4x plus 1, and these are the same. So the process of evaluating is just plugging in no matter what. So let's finish off this example of that -4 plus 8 plus 1. So -4 and plus 8 gives us 4, plus 1 gives us 5. Now what I'm saying here is I want to evaluate when s is x plus 2. So instead of plugging in 2 for s, I'm going to plug in this entire expression for s. So I'll get negative in the front, x plus 2, quantity squared, plus 4 times x plus 2, plus 1. So this is where the s's were. And I just plugged this whole thing in. So the notation is suggestive. If g of s is this thing, then g of x plus 2 should be the same thing where I plug in x plus 2. Now I'll just expand this out so I get minus, I'm using FOIL here to do this part, 2x plus 4, and then plus 4x plus 8 plus 1. Distribute this minus in and combine like terms. My final answer is going to be negative x squared plus, oops, this is plus 4x in the middle there. And when I FOIL, I did that too fast in my head. So minus x squared, this is going to be minus 4x, which will cancel with that one. Then I have minus 4 plus 8 plus 1 is going to be plus 5. So that's my final answer. So again, evaluating algebraically, we're just plugging in whatever is inside of the parentheses in the place of the variable that we had. To evaluate using a graph is even simpler. So the way that we do this is we look at the x value, and then what comes out is the y value. So for example, f of 1, I go to 1, and my y value on the graph when x is 1 is 1. This one's a little tricky because it looks like it could also be 2, but since it's filled in at 1, that's what we write for our answer. Now f of 3, so this is my x value. When x is 3, y is also 1. So f of 3 is 1. F of 4, when x is 4, this is an open hole, so that's not the value of the function there. I keep going up. So when x is 4, the y value is 4. So f of 4 is 4. And probably the simplest example yet, evaluating using a table, well, this is the x value, the thing inside of the parentheses. What I get out is the y value, or f of x. So I just read along the table. When x is 0, f of x is 8. All this says is f of 0 equals 8. So we can think of that as f of 0. This one is f of 2. This one is f of 3. This one is f of 4. I mean f of negative 1, sorry. So f of 2, when x is 2, f of 2 is 7. And that's all there is to the table example. So tables are pretty easy. Now our final example, the hard one, a piecewise function. So all this means is the function is defined in two parts. And you'll see these types of functions a lot. So the first part is defined for the values when x is less than 0. So x is less than 0 here. X is greater than or equal to 0 here. So if x is less than 0, then the function values follow the rule x squared plus 1. So for example, if I want to do f of negative 1, since negative 1 is less than 0, I use rule 1 and plug into that. So rule 1 is this one, x squared plus 1. I plug in negative 1. So I get negative 1 squared plus 1, which is just 2. So if I were to plot this when x is negative 1, y is 2. Now for f of 0, since 0 is greater than or equal to 0, I'm using this rule. So I'm trying to find the value here. Rule 2 is x minus 1 So plug in 0, and we find that f of 0 equals 0 minus 1, which equals negative 1. So negative 1. Finally, f of 1, so my x value is 1. 1 is greater than or equal to 0, so again I use rule 2. So plug into x minus 1, and I'll get 1 minus 1 equals 0, so f of 1 equals 0. So when x is 1, y is 0. So if you know what the graph of x squared plus 1 looks like, you know it's a parabola. We know it's got to go through that point. But it's only looking like a parabola while the x values are less than 0. So it only looks like a parabola there. X minus 1 is a graph of a line with a slope of 1, up 1 over 1, and it goes through negative 1. So this is what the graph of this piecewise function would look like. We have an open hole on the parabola part, a closed hole here. So study this example a lot because it takes a little bit of time to understand, but the steps for evaluating f of x when f of x is piecewise are first figure out which rule to follow by looking at the input. So this is the input, it's negative 1, that was less than 0, so we knew to follow rule 1. And step 2 is plug into that rule. Great, so I hope that this video helped you to understand how to evaluate functions, and if you have any questions, please let me know.